All right, here we are for our first video. This is going to be the A-1 notes for pre-calculus over real numbers. This is my first go at this, so we'll see how well it turns out. A-1 starts out with a bunch of definitions, mostly regarding numbers and types of numbers. The first one is real numbers, and that's going to be the field of all rational and irrational numbers. What we usually do to talk about all real numbers is we use the symbol, it's two lines, and then an R going through it. Rational numbers, so those are going to be numbers that you can write as a ratio. A ratio is kind of like a fraction, where P is over Q. Q is not going to equal 0. We're going to talk about that a little bit later. You can't have a denominator that's equal to 0. Some other things to know about rational numbers. Anytime that you have a decimal that repeats or stops, that's going to be considered a rational number. So repeats or stops. Some examples of rational numbers, you can have 2, any fraction like 3/5. If you have a number with a decimal that stops like 4.05, that would be a rational number. And a pretty famous value that has a repeating decimal would be 1/3, which is just 0.333 repeating. It just keeps going on and on and on. Okay. And then that brings us to irrational numbers. So those are, they cannot be written as a ratio. Some, I guess, easy irrational numbers, pi. If you guys have seen Life of Pi, you'll know that the kid repeats the number pi for a lot of decimals. So, if not, you can watch that. Square root of 2 is irrational. So then anything, if you were to take an irrational number and multiply it by another number like 3 square root of 2 would also be irrational. So let's see. Some other ones that are on here, or that aren't on there, that are in the book, you can have integers, those are just going to be whole numbers. And then they can be positive or negative. Another one that they're going to talk about that I forgot to put in are natural numbers. And those are a lot like integers, where they're whole numbers, but these are only going to be positive, and it's only going to include the number 1 on up. So we're going to just talk about whole numbers from 1 to infinity. So in the book, they're going to have you classify a whole bunch of numbers as irrational, rational, integers, or natural numbers. You can have numbers that are both rational and natural. For example, 2 would be that. 2 is also an integer. So sometimes numbers can be multiple or fit into multiple categories. Awesome. Okay. So some examples here. If you look at this first one, you have a crazy long number. At the end, though, you might notice that you have some repetition of the 7050. And since it keeps going on and on, actually, it comes to an end. You can consider that to be rational. The next one, if you look at this, is 0.01. 011, 0111. Although this has a pattern, it's not really repeating at all. It's going to be considered irrational. So here we go. So that takes care of those definitions in that little first part of A1. The next part gets into inequalities, and we're going to talk a lot about putting that into notation, and that's going to help us a lot when we do domain. So just to kind of go over your regular inequalities, this symbol right here would be x is less than y. Oh, you can't see that, can you? This next one, x is going to be greater than. Here with the little equal sign, you just take what you had up here and then add on or equal to. So this would be x is greater than or equal to. And then this would be less or equal to. So what we're going to do, we're going to talk about notation, which in the past has been pretty new for most of my pre-calc students. What you can do, you can take these inequalities and you can write them in, or actually just display them in two different ways. One way is using set notation. Another way is going to be an inequality, which is going to be the one that you're most familiar with. And then you can take that inequality and put it on the number line, which I'm pretty sure a lot of you have done before. Really, the key thing to know about this is that anytime that you have a symbol with an equal sign, so that's going to be less than or equal to, or greater than or equal to, that's going to go along with a closed dot. And it's also going to, let's see, have brackets with it for the notation. Okay. So those three go together. And then the other case, if you have just an inequality with no equal sign, so just the greater than or the less than sign, on your number line, that's going to be an open dot. And then when it comes to notation, you're going to have parentheses instead of brackets. One thing to note is that infinity is always going to have parentheses. And that's if it's positive or negative infinity. And we're also going to talk about whether the interval is open or closed. I know that the book talks about bounded and unbounded, and we will probably talk about that more in class when we're all together. So just make sure you ask me about that. So here we have notation. It's just AB, and they are both in brackets. So if you guys remember, if you have this little cheat sheet off to the side, brackets go with the closed dots. An example would be like if we had negative 3, 2. When you have two brackets, it's closed. If you were to take this notation and write it as an inequality, you always put the smaller number on the left. Since we have brackets, we're going to use the less than or equal to sign. Any variable you want can go in the middle, and then put the larger number on the far right. Okay. To take this notation and put it on the number line, keep in mind since we are using brackets, they're going to have closed-in dots like this. All you do is you shade in the dot over negative 3, and you shade a dot on the 2, and mark in between to indicate the values of x that you are looking for, or that fit in your set. Similarly here, we're going to have just two parentheses. Parentheses or a double parenthesis means that your interval is going to be open, just like the circle. We can use the same numbers if we have negative 3 and 2. This time, if you were to take it to the number line, you're going to have open dots on negative 3 and 2. And you're going to shade in between. When you go to the inequality, you're going to take negative 3, that's going to be your smaller value, put that on the left, put your larger value on the right, variable in the middle, and then since you have open brackets, you're going to put in the less than signs. In general, all of your signs are going to open to the right. So I guess really, in terms of these, you only need to focus on the less than or equal to sign and the less than sign. Some other random ones, let's see. You can have half open and half closed. If you kind of think of it as being an optimist, we're going to just mostly call them as half open. A half open example would be like this, either of these two. we can use -3 and 2 again. Here we're closed on 3. We're going to be open on 2 because of the bracket on 3, the parenthesis on 2. Again, the same order with the inequality. Just make sure that you fill in the right symbol. Since this one has a bracket, it's going to be less than or equal to. Since this one has a parenthesis, it's going to be less than. Okay. Again, being an optimist, this is going to be half open. When you fill in this, just go along with your little cheat sheet over here. If you have a bracket on a number, make sure that your dot is closed. If you have a parenthesis around a number, make sure that dot is open, and shade in between. Okay. So you can use that information. Go ahead, you can use -3, 2, or whatever examples that you want to fill out this one, and we'll do some of the infinity ones together. A good infinity, let's do this one down here. Here we're going to start off at the value of a. We've been using -3, so that's what I'll use. And we're going to go off to infinity. As an inequality, you can just take -3 since it is the smaller of the two values. Make sure that's on the left with the variable in between and infinity on the right. When you go to draw this on your number line, go ahead, let's see, 3 has a parenthesis, so it's going to be an open dot, and we're going to go off into infinity. All you're going to do is shade in. And then just make sure I can tell that the arrow is bolded so that I know that it's going off forever, because that's what infinity is. So this one, since they're both parentheses, it's going to be open. Anytime you have a combination, we're just going to call that half open. I think you have enough information to go ahead and finish the rest of these on your own. Just keep using A as -3, and you can let B equal 2 if that is in there. Okay? And we'll go over those tomorrow if you have any questions. Okay. Another skill for this section with your inequalities is to be able to kind of think about a sentence and place it into an inequality format. For example, Miss Stevens is at least 77 years old. So you have to think about what that means to be at least 77 years old. I like to say, well, if I'm at least 77 years old, then can I be 78? Can I be 76? So the least I can be is 77. So that means that my age, we'll call that A, has to be greater than 77. And since I'm at least 77, that means I can also be 77 years old. So there's your inequality. You can take that and you can put it on the number line. Sometimes with these, I'll just mark my age or the amount. Since it can equal it, you can have your closed dot, go off into space, show that you're going to infinity. And then the last one would be 77. Since that's the least I can be, that's going to be on the right side of your notation. Sorry, left side. And it's a closed dot, so you can put a bracket in, and you're going off into infinity because who knows, I could be immortal.